Good morning to all. Thank you for coming. My name is Jose Mínguez. I am Head of Innovation Market Iberia. First of all, just two slides to tell you who we are. I work in Market Iberia, Enel Group. We are the first network operator of the world with 73 million customers. We are the world's largest private investor in renewables with 43 gigawatts of renewable energy in the world. We are present in 35 countries in 5 continents. Endesa belongs to the Enel Group. We are the first electricity company in Spain and Portugal. And we have over 12 million customers. But today we are not going to talk about Endesa. I wanted to talk about innovation and sustainability, which is the proposal of this year. Explain you what are we doing in innovability. And first we are going to start with a first block of innovation. And what we wanted to show you is how employees are doing real projects with real people and show you what are we doing. First, I'm going to start myself to tell you how we are innovating with customers. Last year, we presented here at South Summit an initiative being developed by SysDe Labs. We consisted in the virtualization of the control center. The control center manages all the nuclear and power plants of Iberia. And it's a quite complex education that every employee takes. So now, as you can see, we make the first pilot with real employees. They can have this education through virtual reality. We also develop virtual reality, again, with this startup to improve the cells with 2 projects, which is the high temperature heat pumps, which is an installation we are selling to our customers, and solar roof for installations. But we also are developing application of artificial intelligence for our customers. We were the first electricity company in Spain to use Alexa. Now there is a skill of Alexa you can install in your home, and you can ask your bill to give you with your voice. This skill is improving every day with new skills. We are using IBM Watson chatbots and voicebots to increase the satisfaction of our clients. And of course, innovability is to worry about these people who have problems. In this case, this year, we launched a service with an Italian startup, which is Pidius, to allow deaf people who have disabled capabilities of hearing, with a system on voice-to-speech, speech-to-text that is integrated with our call centers. These are only a few examples of what we're doing in Market Iberia for our customers. But let me introduce you Irene Navalón. Irene Navalón is a predictive maintenance engineer who is going to tell you how to use artificial intelligence to reduce emissions and predictive maintenance of our power plants. Irene, please.
I'm a dynamic analyst, and this means that I analyze the vibrations of the power plant machines in order to detect potential problems. You can imagine the potential problems such as a disease that you want to detect in early stage. And the machines that we study are rotative machines, like gas turbines. To detect the anomalies and the problems in early stage allows us to minimize risks, minimize the cost, of course, and minimize accidents, but also minimize the emission, because sometimes we improve the performance, and of course we also optimize the resources. So I think that the predictive maintenance is a must for our planet. To do that, we analyze a lot of data, because in Endesa we have a lot of data. One combined cycle can have more than 5,000 of sensors taking signal every few seconds. And we're looking for in the data deviations and patterns. Deviation and patterns are the best combination for applying artificial intelligence. And we apply the artificial intelligence in two main points. The first is about anomaly detection, because our moving from a traditional system based on static rules to another one based on AI, and our company relations several parallel initiatives in the power plants to detect the anomalies. But after that, the anomalies are sent to the expert to analyze the problem, to do diagnosis. Diagnosis is not only to analyze the anomaly, it's also to detect the severity, the kind of the problem, and the possible evolution. For example, we can detect a thermal sensitivity that is when rotor bow due to an electrical problem, or to detect wear on the gears that to indicate the need of lubricate. But the most recent example it's about diesel engine, that is a diesel engine, and that we did a model to predict the emissions with the target to reduce of the emissions, because we can compare the predict emission with the reals and looking for the main system of the plant which have more impact. We also can define the impact of the maintenance actions. We did that thanks to the data community of Endesa, because we did that between several partners of the different business lines of the Endesa, thanks to the trainers and meetups and datathons that the community organized. I want to highlight that because thanks to the community, I participate in a local community in Seville in order to spread the artificial intelligence, the non-profit Saturday side. Thank you.
Amazing how we use artificial intelligence. We open to really open innovation where we collaborate inside the company with employees, but also outside with people outside the company. And now, let me introduce you to Javier Leiva. Javier Leiva is going to explain us about a project which is Network Digital Teaming. He works in Endesa Distribution. And please, Javier, explain us what are you doing.
Thank you very much. Well, in Endesa Distribución, in the business of distribution networks, we are taking a challenge to build a network digital twin. It consists in an ecosystem where we gather model 3D modeling of our assets, our infrastructures. Also, we add different layers with all the data that we collect from sensors, all the technical information that we have in our systems. Also, we put in the hand of our colleagues all the information to take action and to make operations safer. And overall, we build a platform where we can execute artificial intelligence tools to go farther from the data that we collect and to extract useful information for the business. And also we have a kind of data lake where we can share the information with our colleagues, with different parts of the company, and also with third parties. That first layer is about 3D modeling of our assets. We have more than 13 million customers in Spain. We have thousands of infrastructures. So to have the most accurate model of our installations is a key enabler for us for the following steps. In fact, we have some images of on-ground operations that we completed to build this 3D modeling of real infrastructures. In addition to this, we have a second layer of Internet of Things and edge computing capabilities. We have millions of data, day by day, hour by hour. So the key is to build useful information to see the performance of our assets, also to merge information coming from different fields, thermography, photographs, human inspection, data from smart meters, from sensors of any kind. And over this, we build a human interface, because it's a key that our colleagues can have a real training with virtual reality to know perfectly the infrastructures where we have to performance our business. In addition to this, we have also augmented reality and APPs to have a safer operation. We have information of the problems that we have to overcome, where our workforce is taking operation, and we have everything in an integrated platform with different software. And to conclude, the idea is to build a unique model where we have all the information gathered, where every user of the platform, every user of the ecosystem can find the information that he needs. We can make simulations, we can have a real model of every of our infrastructures, and also we can build a creating shared value ecosystem where we can, first of all, we can have a deep analytics of the performance of our infrastructure. We can have a better diagnosis of how is occurring in our grid. We can take also operation before any kind of incident occurs. And also we can share that information with third parties, as I said. If we have distributed energy resources, electromobility systems, aggregators of any kind of smart user in our grid, we have this advanced information to do our work better with the network, and also to provide tools for them to have a better performance. So the idea is to build that digital twin of the infrastructure that we have in the street to work with it. Okay? Thank you very much.
Amazing. With all these studies from the people from innovation distribution, what we get is our grid is stronger, ready for natural disaster, ready to anticipate failures. And thank you to all. Then we have the magic that we switch on the light turns on every day, 24 hours by day. And now we're going to talk something a little bit different from distribution. Let me introduce you Javier Tejedor, non-technical losses detection, and they're in charge to look for these people who really are stealing the electricity. And how do we do this? He is going to explain us to us. Please.
Thank you, Jose, and good morning to everyone. Let me introduce a real use case in Endesa Distribución where we are applying artificial intelligence, in this case, to non-technical losses detection. Non-technical losses are a relevant economical problem not only for our company, lower revenues, but also for the society, lower tax collection, or even unfair competition between companies. But non-technical losses are also carries also danger, like electrocution or even death for those who perform it, and even an increase of the risk of fire for the neighbors. The main types of non-technical losses are direct connections, double connections, meter manipulation, shunts, sophisticated electronic fraud, or meter malfunction. But the question is, how can we detect a fraud when we have 12 million customers in an efficient way? That's why in Endesa we are using artificial intelligence, machine learning and deep learning over the big data to do it in an efficient way. We are working into two approaches. First one, a supervised machine learning approach. In this case, we build the features based on our business and technical knowledge to build the training and the prediction data set. These data sets feed three different classifiers: two gradient boosting decision trees, XGBoost and LightGBM, and one deep neural network with Keras and TensorFlow. Over these three models, we have a second level model, a model stacker, which outputs are the final predictions. But on the other hand, we have a supervised deep learning approach. In this case, we don't engineer the features, but we provide almost the raw data to the network. We have two different neural networks, one of them for non-sequential data, for feature extraction, and another one for sequential data feature extraction. The output of these two networks, concatenated, are the input of a final deep neural net classifier, which outputs are the final predictions. With these two approaches combined, we are obtaining a 45% success rate in more than 125,000 inspections this year. This doubled our best numbers a couple of years ago. But we are keeping improving, analyzing false positive, false negative, engineering new features, fine-tuning our models. So I can tell you that artificial intelligence is really helping us to improve non-technical losses detection. Thank you.
Thank you. Now, we want to do something different because I feel sometimes when we participate at the panels that like all the questions are a little bit cooked. So now I want you to be part of this. I want you to make the questions of the things you think it might interest. So I ask all the speakers to go up, please, some chairs. And I want you all to think questions about the projects and things that it might interest you about what are we doing, how are we doing the projects. These are the experts, so microphone. No, me pongo donde quieras. I see a question there.
Hello, thank you. Okay, so my name is Adrian Garcia Ramos, and my question is related to the energy efficiency. So I've seen that you guys have developed a lot of abilities regarding deep learning, and I just wanted to know if you are working on that field in order to increase the energy efficiency by transforming the the signal of the electricity depending on the different devices that you have in a given home or a commercial building, and support your customers to reduce the consumption. Thank you.
Okay, I answered that question. We are going to talk about energy efficiency in the second panel, but with the projects we have talked, I think Irene can tell how artificial intelligence is being used to make more efficient the generation, which is a very important part of the efficiency, because once you make your power plants, they are going to be more efficient. But anyway, you can ask that question to the expert who's been in the second panel. So please.
Yes, I understand that you want to about the building efficiency, but in the generation part, we also try to have more efficient turbines, of course, and processes. To do that, we analyze the operation data. We are combining the different signals, temperature, pressure, vibration, and when we have some deviations, I analyze the case with experts.
Please, microphone. You have to think that if you improve by 0.1 points a power plant, that's a lot more than if all the customers do whatever. So, and even in the green, I don't know if you want to add something of how.
Yes, with the help of the algorithms that we use in this model, we try to determine the technical losses that we have in our system, in our transformers, in the cables, in every point, which has a technical, a scientific explanation. With the help of that information, we can better plan in also our operation and maintenance. We can be even preventive And also, we can determine the technical losses of the system to help another colleagues to make their job, because he can better differentiate if the energy losses are technically reasonable or if there is another incoherency.
To give some figures, maybe you can give more precise that the losses in low voltage tension are around 7% of the energy, which is huge. But this is something you really can do little. There's like 1% in the transformation when it transforms from different levels of tension. And in the highest level tension, I think it's around, depends a lot of the level of the tension, between 2 and 5. No? That's the good figures. That's a lot of, so any optimization we do in the grid is going to go straight away for every customer to the whole system. This is why smart grids are so important.
Hello,
Hola.
Hello, my name is Ana Galvez from Technatom, and my question is for Irene. You have explained that today the diagnosis is performed by experts. What do you think is needed, and if we are on the way to get automatic results or automatic support for diagnosis?
Okay. We are working in the vibrations, and we are moving the vibration studies to artificial machine learning models. But I think that is a long process, because first we have to create a good model to detect anomalies, and then create a tie between the detection and the thorough analysis. I think that the vibrations is the more powerful tool to get the predictions of the diagnosis, and after that you can combine the vibration with temperature.
Hello everyone, this is Aleceia González from Naturgy, and I have two different questions. One of them is for Javier about the technical losses, non-technical losses. Have you, with the second approach, the deep learning approach, have you identified any variable to explain what kind of customer is stealing the electricity?
Well, with the second approach, I don't know if you can hear me. No. Okay. The second approach, the neural nets extract the features for us, so it's difficult to interpret. We know we are detecting fraud, but still don't know well what is in the network. It's really in some time. In the first approach, we control everything. We know which are the features. We can build the feature importance, and we know which features are working. There is a field of study, the interpretation of neural networks.
And my second question, if I'm able to ask, is for the four of you. And my question is, do you develop the solutions by yourself, or do you work in an open innovation approach? Or how do you have data analytics experts or artificial intelligence experts at the company, or do you work in an open innovation approach?
I'm going to reformulate the question. We have 40 minutes left, so we have plenty of time. Keep thinking questions. I'm going to reformulate the question for all of you, and I'm going to be the first to answer your question. How important do you think is the open innovation in your projects? Okay, and for the innovation perspective, as a innovation responsible, not only in artificial intelligence, but specifically in artificial intelligence, we have two communities that are very important, which are the data scientist community she mentioned. But what we do there is that we put together all the people that they talk the same language, because we are doing artificial intelligence in many departments. You have people from prices, people from customers, people from generation, and it's really very rich when they all come together and talk the same language, because you know at the end the algorithms are the same, the difference, the information you put to them. And the second community we have with the NL group is the artificial intelligence community, and there has another perspective, because there are, I think, a higher level of who are we working with, and we put together all the projects along all the countries of NL Group. I participated in this community, and we are seeing the results. For example, we developed Alexa in Spain, and the team of NL in Italy came to us to see how they could implement it in Italy, because it doesn't make sense a global company of us have departments doing the same. So we learn from each other. We learn from the employees. We learn from each other. Watson, for example, which is another case of open innovation. Everybody knows Watson. You know the product of IBM. So we are learning all together the use cases and the application of Watson in every country, and you see different perspectives from different the countries. Of course, every country sometimes has their particularities, but the technology, which is the common language in the communities, is the same. And to end and give you a little bit of speak, again, in the open innovation model, you can see that we are working with universities, with startups. We brought that here some examples. There are more examples. You will see in the second panel more examples. But for example, Six the Lab is a startup. We made a scouting, and we weren't seeking for a startup. We were seeking for the best solution, and the solution was developed by Six the Labs. Why? Because they were good. I mean, we are business units. We want business. We don't want just do something because we like them. But I think all of you have examples of collaboration in the open innovation model, and you can give more examples.
In our case, in Endesa Distribución, in the non-technical losses detection, we have worked with the university, also with some small companies at the beginning, but it didn't work very well because it's quite difficult to understand our data in Endesa. We have huge quantity of data, different systems, so you spend a lot of time to really understand data. So basically, we have a data science team, internal data science team, complemented with some data scientists external, but working in agile all together in the same room, and it's the best way I understand to work, because it's difficult when in a big company to understand contracts, version of contracts, devices. It's difficult to understand our data. So in my opinion, we are working with internal data scientists right now with some support of an external company.
Mm-hmm. In my case, I come from Malaga, and there we have a living lab with around 20,000 end users, real end users. So we have a mix of startups, universities, and our colleagues of the business lines. So if we need to develop something, we have more support from the university and the startup side. If we need to scale up or try and scale up a more mature solution, we have the support of our business lines. But the key for us is to test in real operation conditions with problems, with incidents, with eventualities.
And in my case, I work with vibration, and vibration are also a difficult data, but we have collaborated with universities because we are open to collaborate, only looking for the expertise.
To add a little bit more, because I have been models responsible for many years. Anyone who have worked with data knows that the time it gets you to understand each variable, where it comes from, which database, to clean that data, to detect anomalies in the data, that's a a lot effort for when you really want to model. You know, I always say rubbish in, rubbish out. It doesn't matter what model you have, and we spend a lot of time on that. So many times when you think, okay, this project I'm going to try to bring up someone from outside, a university, a startup, you realize that sometimes the effort to explain this is so hard that it depends the use case. I'm not saying that you can't get help from the startups, because we have projects where we have startups that have become big, but anyone who have developed systems with data know how complex is the understanding of the variables. And you can explain that like, I'm going to explain you all the silence from the generation. I mean, let me explain you that. You have there a person who has been in the power plant, and sometimes we find that this in the one of your projects, when the data scientists explain internally the project, say, yeah, but at the end you have the technical guy who didn't know anything at all, and say, no, look this signal, I know when it gets red something's going to happen, and you start to work with this model, but with the expert in the field.
Just one more thing. In our case, 90% of the time is from raw data to build the features. And for example, we are training with all the inspection we did in the past, from 2010 till today. But in the meantime, the system changed, the information is recovered in another way. So you need to know very well how it works inside our company, the different systems.
We still have 6 minutes left. More questions? The side ones,
So,
please. Raise your hand.
I think that I was not clear enough or specific enough with the question that I made before, so I'm going to reformulate it in a specific way. So the thing is that I know that by transforming the energy curves from the time domain into the frequency domain, you can know whether your home appliances or other machines are working well or not, right? So when I talked about energy efficiency, what I was talking about was about recognizing, maybe with preventive maintenance or preventive algorithms, whether a given fridge in a house is working well or it needs a replacement in order to improve the efficiency of that home appliance. And you guys have, you said it, you name it, like 12 million customers. So if you were able to recognize those machines that are not working properly and replace them in order to improve the efficiency, that could be a great support for your customers, right? So that's a focus of my question. I don't know if you can reply to that.
Yeah, but we are going to talk that in the second panel. So I ask you.
Clear. Excellent. I've got to say.
From the point of view we are discussing here, which is the generation and the grid, clients are transparent.
Okay.
Because the grid is a perfect system with perfect frequency.
Yep.
And that's the job. Make that you have a perfect signal on your consumption point. We will talk later.
Clear.
Efficiency at the customer point.
Second question. I live abroad today, but I was born and raised in Tenerife. And as you may know, something bad happened in Tenerife the other day. So I just wanted to ask you if you are making plan and provisions for deploying distributed energy assets among the distribution grid, taking profit of your algorithms and innovation projects.
No entendía la pregunta.
¿Sabes bien el caso de Tenerife o lo cuento yo?
¿Qué caso es? Es que no...
Tenerife.
Cuenta.
Well, the blackout that happened in Tenerife wasn't caused by distribution grid. It was caused by red electrical grid. And I'm going to explain something from distribution, and you know more than myself from distribution. When something happens, because I read something in the media, when something happens in a distribution center, you can do nothing because the system have all the protection to outside, not from the inside. You can't do anything. This happened in Barcelona a few years ago. It was a huge blackout in Barcelona. You can't do anything at all. The system is not perfect because being perfect is infinity cost, and at the end we will have to pay. It's a nonsense. If a ray blows transformation, high voltage, the grid is going to black out. Especially in an island where it's more difficult to turn it out because there are less generation, okay? And the second question, we didn't understand.
The point is that if you have any innovation project to planify the deployment of distributed energy assets within the distribution grid?
Well, the deployment of the distribution grid, there are two deployments. The deployment of the customer is not controlled at all. Any customer can deploy solar generation, so the smart grids have to be ready for that. And the deployment of the generation at a higher power level is deployed by Red Eléctrica. They have to ask Red Eléctrica because the grid has its restrictions. Who planifies the development of the distribution is Red Eléctrica. And of course, it is, and the reason why that's Red Eléctrica is to have a person who is not involved in the Endesa's grid. So this is done, but this is done by law by Red Eléctrica. If you want.
Yeah. Also, in our case in innovation, we are beginning to search the concept of local markets, in the way that you have a global market, approaching that local market with a correct coordination among the distribution company and the transportation company. Because in the future, in the next future, we will have to host that market, that services. We will need to exchange information with smart agents, active agents. And also we are testing as well to have distributed energy resources in the side of the distribution company, like energy storage or technologies like this, to help the grid to have a better performance in the case that you have a necessity of voltage regulation or something like that. We have it in our scope, but it also has a lot of regulatory issues because right now it is not considered for our competencies, but it will be, in the next future, it will be something to be taken into account.
For example, one of the projects we looked for this was Graciosa project. We developed it in the Graciosa Island because with very little generation, you get a lot of impact on the island. Graciosa is a very tiny island. And I have said, we worked together, Javier and I, so I'm very proud of that project because it was my project. But at the end, was that you study how the customer is going to behave in a solar distributed system where we know everyone is going. So, please, anyone else has question? Because anyone? We have last question, 1 minute. Somebody else? If not.
Hello, my question is about the digital twin. You have explained a nice and complete model. What is the maturity level? Is something that is real today or is in development process?
In the case of aerial lines in the high voltage, every year we have with helicopters, we have a modeling of a third part of our network. So every 3 years we have a renewed model of our aerial lines. The key in the network digital twin is to transport that way of working to the medium voltage and even to the low voltage assets. In that way, we saw that pictures of substations where we are collecting the modeling, the infrastructure, by using commercial scanning. The key in this case is the processing of the data, because you have a lot of photogrammetry, you have a lot of points. It is LIDAR technology, laser LIDAR technology, and the key for us is to answer the question of how is this information useful to. So we are testing technology, including in our workforce management operations, and looking for business case to have a benefit of taking part. But it is a mature solution. Mm-hmm.
Well, thank you. I think you own a big applause. And now we are going to the second part of the innovability. We have talked of innovation. Now we are going to talk about sustainability. We have the first question ready for you, Jorge. I think you are going to answer a lot of things about energy efficiency. So what are we going to see in this block? First, let me introduce you to Jorge Pina, Head of Environmental and Climate Check of Endesa, who is going to tell us a little bit about sustainability.
Let's kick it off. It works already? Okay. Good morning, everyone. I think we are somehow privileged to be living in a period of great changes, a period of a huge transformation. And I think that we will all agree that one of the main drivers for this transformation is the sentence on the slide behind. We do not have a planet B. And because we do not have a plan B, we need a huge amount of concrete and immediate action. In the next few minutes, I will be explaining some examples of concrete action that we develop at Endesa. I'm not trying to convince you that Endesa is the greatest, greenest, and most sustainable company in the world. What I'm trying to do, or what really motivates me to be here in the States, is trying to get some real action from you. See that we all together can have a real impact. So first example of concrete action by Endesa. Decarbonization. On the slide, Greta Thunberg and science. On the last few months, Greta Thunberg has been able to get more attention than what science has been able to get in years. So I try to help science a little bit here. Do you know what science is telling us about how is the exact point in the fight against climate change? Well, what science is telling us is that even taking into account the Paris Agreement, even taking into account the efforts under the Paris Agreement, by the end of the century we will be 3 degrees, temperature increase will reach 3 degrees, and that this will have catastrophic consequences for planet Earth. And what is Endesa doing? On year 2005, Endesa emitted 50 million tons of CO2. As today, we are emitting 30 million tons of CO2, and we are committed to be fully decarbonized in the year 2050. We will be a zero emissions company. Second idea, second example. You probably all remember the controversy between Bolsonaro and Macron from last summer. There was this huge fire in the Amazon, and Macron blamed Bolsonaro for not doing enough, for not being climate responsible. Up to some point, Macron was right. The Paris Agreement states that we must get to a balance point, a balance between emissions and absorption. And of course, the greatest absorption potential that we have are forests. If we lose the Amazons, if we lose our forests, we will have no chance in fighting climate change. In Spain, we don't have the Amazons, but we have fires every summer. In Endesa, we have this initiative, Endesa Forest, El Bosque Endesa, by which we reforest, every year we reforest forests in which that has been destroyed by fire. We started with this initiative in the year 2016, and in a couple of weeks we will be starting reforestation in Doñana National Park. You probably all know Doñana National Park, one of the most important natural areas of the Peninsula Iberica. Third and last example, biodiversity. Here, what science is telling us is that there are about 1 million of species, plants, and animals at risk of extinction. And here, what Endesa is doing, we have a biodiversity conservation plan. Every year, we develop 25 projects to preserve biodiversity in the Peninsula Iberica, and especially in the areas where we operate. So I said at the beginning, I was trying to get some action from you. So if I have time, I don't know, Pepe's already looking at me. Is there anyone in the hall from Barcelona? Jorge, I knew you were coming, so this is what. Jorge, did you came by plane or by train? By train. Okay. Do you know that a plane Barcelona-Madrid, Madrid-Barcelona, that's about 140 kilograms of CO2. But if you do like Jorge, if you come from Barcelona by train, you are emitting 12 kilograms of CO2. So there you have an example, something you can do to develop your own action, your own concrete action. Thank you very much.
I'm glad you didn't say he have to go in by boat like Greta did to New York, because we have a hard time. But amazing, 100% free CO2 generation. We are on it. The energy transition is coming. Now, let me introduce you Antonio Castellanos, Circular Economy Iberia, who is talking about sustainability. Antonio?
Thank you very much, and good afternoon. Okay, innovability is about innovation and sustainability. But innovation is a mean and sustainability is a goal. These are two different concepts. Innovation is a mean to achieve a goal, sustainability. Sustainability needs innovation, and innovation needs to be sustainable. In fact, if innovation is not sustainable, it probably won't prevail in time. When we think about innovation, we think about sustainable business models or at least sustainable from an economic point of view, but sometimes we forget about the impact that innovation has on the environment and on society. You have to understand that the two components of sustainability are economic, environmental, and social, and this is very important. Excuse me. Here we have if you need inspiration for sustainability, let me present to you the 17 Sustainable Development Goals as declared by the United Nations. You will find a very good source of inspiration here, trying to do innovation for a better world. Another thing you must consider is how your innovation scales over a large volume of customers and over a long period of time. It's important to consider the circularity of your product and services to really, during its whole life cycle, to really assess the impact that it will have on the environment. Amazon, for instance, is a very successful business model, but recently they announced that by 2040 they will become carbon-free. They have purchased 100,000 electric trucks from an American company called Rivian in order to make the delivery of their products to their customers more sustainable. This is important. They're finally realizing that operating their business is causing an impact on the environment and they're doing something about it. Good. At Endesa, we believe that the future is electric. In fact, from the supply side, we are working on making the generation of electricity more sustainable. From the demand side, we're also working on a concept called the electrification of energy demand. What this means is eliminating fossil fuels and substituting fossil fuels with electricity. Electricity is a form of energy that is clean, is efficient, and it can be produced locally using renewables. And this is very important. Specifically in the sector of transportation, about 30% of emissions in the world come from transportation. 5 years ago at Endesa, we launched this project that has to do with, it's called the Electric Mobility Plan for Employees. And the objective of this project is that by 2020, 10% of our employees will drive electric cars. Actually, by the end of this year, we will have 900 electric cars for our employees. They're driving electric cars. One of the most interesting things that we learned with this project is that if you offer a more sustainable product to the market at a competitive price, and this is not necessarily equal price, customers will choose the more competitive product. This is a fact. We've learned about this. Another interesting project that we're launching at Endesa, it's called Zero Plastics, where we are engaging our suppliers and our employees to eliminate single-use plastics from our offices and from our facilities and buildings. In 5 years, we expect to eliminate all single-use plastics that we use in our offices. Just as a final remark, let me say something. When you innovate, it's important to consider, of course, the economic sustainability of your innovation. But please don't forget the impact that it may have on the environment and, of course, on society. If you're not innovating for a better world, you're probably innovating for a worse world. Thank you very much.
Thank you. Thank you. Thank you, Antonio. It's amazing when you go to the parking slot in Endesa and you see so many cars, because of course in Madrid we have a lot of cars, but this is not happening only in Madrid, it's happening all over Spain. And when you go to the water dispenser and you are going to get a glass of water and there is no glass, because you have to take it because there's no plastic. So I think these initiatives are great, and any company could do them. But now let's go to another important matter. We have an electric car. I have an electric car, but there is not enough charging points. So here, Pedro Arteaga, Business Development Manager, is going to help us putting chargers everywhere. Please, Pedro.
Thank you very much, Jose. Good morning, everyone. So when Jose told me to come here to the South Summit to talk about our project, I got really excited. But then he told me, Pedro, you need to find a shocking title for your presentation. And I started thinking. And it only came to my mind typical things for TV commercials, statements, electrify your future, or something like this. Didn't like it. But then, 10 days ago, I went with my family to a wedding, South Spain, in Granada. And we get there, we went to the parking lot, find the charging station spot, and I plug my electric vehicle. And my oldest daughter, who is 4 years old, asked me, Dad, don't you put gasoline? I got impressed. But then my youngest daughter, who is 2 years old, asked me, Dad, what is gasoline? That really got me. I got my title for the speech. But it might seem anecdotic, and probably it is right now. But my question is, will it be? Will it be anecdotic? In 30, 40 years from now, can we be so sure that the kids won't ask this? So, if I ask you right now, what are the main barriers for you to adopt a sustainable way of transport? Will probably arise these three topics that I mentioned right here. The price, the autonomy, and the charging points availability. In terms of the price, we are already seeing in the last 3 years how the prices are dropping with the launching of several new models for the electric vehicle. And we expect in 2-3 years that the electric vehicle will reach the parity in terms of cost with the conventional vehicle. And achieving a massive targeting. I think that's very useful for the industry. Regarding the autonomy, right now in 2019, if you look in internet, you will find models with more than 500 kilometers of autonomy, right now. And out of several models with autonomy higher than 350 kilometers. And 500 kilometers probably is the mental bridge that we have in our mind, especially here in Spain. And then, as my colleague Antonio said, in Endesa, we've been working with the electromobility since 2011, but always from a private perspective. And we realized it wasn't enough. So last November, we launched the Public Access Infrastructure Plan, which consists in developing 8,500 charging points across Spain in the next 5 years, divided in 2 phases. First phase, creating a net of 2,000 charging points in order to reach every municipality and big city and main road in Spain. And then, in order to reach the 8,500 kilometers, what we are going to do is to install more charging points according to the demand needs, to the EV user needs. And we are trying to do this with some criteria. We try to put some thinking on this. Because the domestic charge, you probably will say me, Pedro, but it takes 6-8 hours. That's not feasible for me to do it. So what we're trying to do is to install a quick and fast technology, the quick technology takes between 1 and 1.5 hours to fully charge your car, and the fast technology will last between 20-30 minutes most, depending on the battery. And we are focusing those quick technologies to shopping malls, hospitals, parking lots, in order to match the time that the user and the client spend there with the charging needs. And the fast technology, we are installing it in service stations, mainly near main roads, that there is no many services. So I would like you to invite later to reach me out in the hall to see how the project is progressing, to discuss how can we collaborate. I will be more than glad to attend you, but I want to emphasize that this is happening, and this is happening right now, not in 30, 40 years from now, right now. So thank you very much.
Thank you, thank you, Pedro. I'm sure it's happening. You know, many car manufacturers are announcing already that they are stopping developing combustion engines. For the next year, there are like 48 models that are going to come to the market, and of course, we are going to need a strong network to have it anywhere. Technical problems, don't worry. There we go. Now, at the end, the question has been asked so many times in the previous, so the customer has a lot to do in this energy transition. How do we do that? With smart systems that are going to let us to reduce our consumption. And who better to talk about this? Jorge Bistue, Head of Flexibility. Please, Jorge.
Thank you. Hello. Well, artificial intelligence. Well, maybe at this time of the day, here, I'm the 500th person who says artificial intelligence. So maybe I'm not original, maybe I'm not innovative, but I will try to explain you a real and practical example and how it is helping us to reduce our customers' energy bill. In Endesa, look, we have a service, we call it an energy management system, we call it SGE, and it's basically a service based on a platform, and an amazing platform, which is constantly tracking our consumers' energy use. And it's been a very successful service, but we thought that we could do it even better. Let me show you. Look, this is the monthly consumption of customer A. Can you tell if it's been efficient? No, you cannot. You need context. Let's put context. Let's compare with another customer, customer B. Okay, it seems all right. It seems efficient. But what if I told you that customer A is a hotel and customer B is a factory? Well, sector is important. We need to put it into the equation. Okay, let's compare with another hotel. Customer C is a hotel. Okay, but maybe one is in north of Norway and the other one is in Canary Islands. Maybe one has 5 stars or an indoor pool or twice as many number of beds than the other. So you follow me. We need data. We need data to fine-tune the accuracy of our analysis. And the more the data, the greater accuracy and greater the savings that we are able to achieve for our customers. The good news is that in Endesa we have a lot of data, and not from 1 or 3 customers, but hundreds of thousands of industrial and commercial customers. And many of them are constantly monitored by our system. These are real cases of examples of our customers. So we have a lot of data that is constantly feeding and constantly training our brains, our engines, and that help our system to say, for instance, to detect anomalies that could go unnoticed by our experts, because our experts cannot be everywhere, cannot see everything in our customers, but our robots can see everything. Our robots can see everything. And for instance, can say that in this building, there's a problem with the lighting. The lighting is wasting money. Or this other customer has a problem with the air conditioning. It's out of date. And the good thing is that we can do this without being here. We can do the recommendations from our desk. And this is saving us a lot of time and improving dramatically our performance. But let me put the focus on a third example that this is just innovative or disrupting. This is demand response. What is demand response? Demand response is when customers actively participate in the electrical market. And how can we do that? Well, simple. This is how our system operator is constantly balancing the electricity demanded by all the consumers with electricity produced by all the production plants. every minute, every second has to be this balance. But what happens when suddenly a production plant has a failure? Well, something has to be done. Traditionally, the system operator asks for a backup plant to replace this energy. But usually, this backup plant is more expensive or more polluting or both. But there's an option. The option is that thanks to our intelligence, thanks to our deep knowledge of our customers' habits, our customers' flexibility, we can ask a group of them, we can agree with a group of them to reduce slightly their consumption in no essential parts. And in aggregation, they will offer us the same energy that is needed to balance again the system. They act, in fact, as a virtual plant. And we will pay them for this service. So this is great because we are empowering the customers, and thanks to smart systems, we are putting the customers in the center of energy transition. Thank you very much.
Thank you. Thank you all. Again, we're going to do the same. We are going to have a panel. Please, all the speakers, come up the chairs and get ready your questions. I have some questions, but I prefer that you make me the questions. Things interest you. Anyone who wants to make a question, please raise the hand, and people from the organization will give you a microphone, okay? Someone to break the ice? Well, if not, I'm going to start with a first question to you, Jorge. Okay, energy efficiency for our customers is cool, but what about money? Because the first thing they ask is, how much is going to cost me? Is this really efficiency and profitable? I think that's a question that a lot of people ask. How these platforms help to?
Well, yes. Hello. Well, obviously, not just monitoring. We can produce savings, but as is used to say, if you don't measure, you cannot act. You cannot be more efficient. So the measurement is a way of detecting automatically patterns of bad use of energy, and to detect where can we attack to reduce this energy consumption. So in fact, we estimate that we can just monitoring and following this monitoring, we can save roughly 7% of the consumption of energy for every standard customer.
Please, if anyone wants to make a question, raise your hand. If not, I keep asking questions, okay? But I keep, the infrastructure project, there are many companies who announce 1,000, 2,000, 3,000. It's very easy to make an announcement. What are you really doing? How is the plan? When are we going to see this? How are you doing? I think you can give good examples of customers who are really putting the charging points. Tell us a little bit more about the deployment of the infrastructure.
First of all, I would like to remark that we communicated this industrial plan to the market, to clients and partners, and we are going seriously with this. So in 10, 20 years from now, we expect to be doing this, and we expect to be selling energy through this charging point. So it's a strategic bet from Endesa. Landing the project a little bit, as I said, at the end of the next year, in 2020, we expect to have 2,000 charging points installed and in operation. But at the end of this year, you will already find around 1,000 charging points. This will be mainly located in the main roads, the A4, A3, A1, but also in the big cities, in parking lots and some hotel chains. So I cannot reveal everything we're doing right now because of confidential terms, but I can guarantee that you will see that. And hopefully, if you also know about locations that might be interesting, partners, clients, and companies, I'm so happy to talk to you and to to go deeper in the opportunity and to land the terms and what are we doing in a more concretely way.
And Antonio, a question for you. You know, when we started the employee plan of cars, I think it was very funny because the first cars, they had like 100 kilometers range. People say, what are you going to do this? This is not a car, this is a toy. And you have lived this until now, where there are even people that they are expecting the brands. The last experience I have, some brands, they don't even have stock to the clients that don't want to buy a car. They have problems to provide this stock. Tell us how have you lived these phases, these last years?
When we started this project, that was 5 years ago, it was a very innovative project because there were, excuse me, hello? Okay, when we started this project 5 years ago, it was quite innovative because at the time there were not that many electric cars in the market and they were expensive, so it was not easy to find a value proposition for our employees to actually become part of the initiative and actually participate and buy the electric cars. So what we did is we designed a value proposition that mostly worked on the barriers that we identified that kept our employees from wanting to participate. The main one, probably, and this is real, was lack of knowledge of electric cars. Nobody knew much about electric cars and nobody really knew whether an electric car could actually solve their mobility needs. So we explained, we showed, we let them try them, and this really worked. The other thing that is quite important is the price, of course. And this has something to do with what I mentioned in my presentation. What we did is we realized we tried to, our offer to our customers is a renting, is a car in a rental monthly flat fee, okay, for 24 months or 36 months. What we did is we looked at the market and realized how much it would cost to rent a thermal car, a normal combustion engine car, and then how much it would cost to pay the renting fee for an electric car. And we saw there was a gap, okay? So what we did is we looked for budget to be able to reduce that gap and make the price of an electric car as close as possible, not equal, as close as possible to a normal combustion engine car. And this was the key, like I mentioned. Of course, we also offered another benefits, such as, for instance, if you have an electric car, you have preferred parking in our offices, so that really helps a lot. But the main thing, like I mentioned, is we tried to make a more sustainable product closer in cost to a non-sustainable product. And when you have that, then everything, the magic happens, and everyone wants to have a sustainable car. Let me say something also that I consider interesting. This project has been going on for 5 years. We launched in 2015. And at the beginning, most people that participated in the project were mostly interested in saving money. For them, an electric car was about saving money because you could use electricity instead of gasoline or diesel. And this is true. But over time, we realized that the second component that we wanted to emphasize in this project that has to do with a sustainable lifestyle actually works and works well. People wanted to be in the project because they wanted a more sustainable product, because they want to participate in initiatives that make the air cleaner in cities. They don't want to pollute. They want to show their children or other people that they're driving a clean car. And this really is a big claim from the point of view of selling a product or a service. So this is another one of the main lessons that we've learned with this project, that actually sustainable products are easy to sell.
And I finished this round and we go with you. And the obligate question is good with electric car. You eliminate local emissions in the cities, but how is this energy generated? You know, a lot of people say, okay, you are saying that the car doesn't have emissions, but there are emissions somewhere else. Jorge?
So it's good, Pepe, that you made this question because it allows me to connect my presentation to what Pedro and Antonio told us. I said we were decarbonizing our energy generation mix. And once we have decarbonized our energy generation mix, we need Pedro. And Pedro, with his chargers, he's putting this free emissions energy on transport. So therefore, we are not only decarbonizing now, and then Antonio, of course, with his electric vehicles is also making this possible. So by decarbonizing our energy mix, we are not just helping or fighting climate change, talking on electric generation emissions, but we are also decarbonizing other sectors as transport.
Well, that makes me think a lot. I work in innovation, and there is like I would call like the innovation anxiety. Like we want everything now. It seems like you put the advertisement on the media, and now you want everything to happen. I think this takes time. If we have time for this a new run, I'm going to ask you about how much time is going to take flexibility, how much is going to take the deployment of the network, how much is going to take that we are zero plastic free. You already said how much is going to take us to change all the generation. But first, I have one question from the public.
Hello, I'm Jakubas from Shine, and I wanted to ask, you're probably aware that there was recent changes in regulation that considerably improved economics for residential solar. So there should be a good, strong push in the demand for that. What's your plans in that segment? What new services for the customers you are planning to offer that will choose to go solar and install the panels on their roofs?
What was the question?
Yeah, I understand. Sorry, we couldn't hear very well. I understand that your question is about solar distributed power plant, right?
Yeah, about the residential solar for, at residential houses. So there was changes in regulation recently, right? And that considerably improved the economics of the residential solar. So this should result in the stronger demand. Customers will be willing more to install the solar panels on their roofs, right? So do you look at that segment, and do you plan to offer any new services for the customers who are not only consuming electricity, but they are producing also electricity?
I can answer that, but I don't know. I think you can answer if I can have some about this.
Okay. You answer.
Well, I answer the question. One important thing about solar distributed energy, when we started, if you started to see this backward, solar energy costed around 450 euros megawatt, which was something astronomous. It wasn't economically viable. But of course, the government wanted to improve this solar because we are a country with a lot of radiation. In the last year, this went down little by little, and we have in the system what is the deficit of tariff, which is a debt of the deficit of the tariff. Now the government has changed the law, which is called Impuesto al Sol in Spain, but now you don't have. So the solar who is being installed in Spain in local consumptions and is without any kind of incentive. So your question, the regulation has helped. I wouldn't say that regulation has helped. What is helped is the technology. The technology now is competitive. There is a huge amount of solar installation being done by Endesa and by other players because now it's a competitive energy system. We have another brand, is not present, of people who are developing. If you can see it on the website, I presented in the first panel selling this to large customers, also to B2C customers, and this is a value proposition is being sold by our customers by Endesa. I don't know if you want to add.
Well, I was going to say more or less the same. In Spain, we don't need anymore a feed-in tariff or a grant to do financially interesting the solar plants. So in Endesa, we are offering this service for all the customers. You can enter in our website and ask for an estimation for a photovoltaic plant, even if you are a residential or even if you are a company. So I think the current regulation is quite friendly for now, since the last year. So it's new, but it's friendly.
More questions? We have still 7 minutes 50, so please, I think it's more interesting if you make questions that we say, so please raise your hand, the one who's thinking I got this question, but I don't feel like it. Please, more questions. I don't know if you did too good, too well, or then we make the second round, but I really encourage you to make questions. The second round, when? The first question to you, Jorge, I have been hearing about flexibility markets. I think England already deployed this, which is been very successful. When is this flexibility markets, what we talk all the time, is going to be a reality in Spain?
Okay. Okay. Well, not only in UK, the flexibility markets are a reality. A long time ago in US, in UK, in France, Germany, Italy. Last year there was started a pilot in Portugal. So it's a reality. We are surrounded by it. So it will be a reality in Spain, not only because it's a trend, because it's mandatory. There's a European regulation that requests for all the countries to implement a flexibility market. So it will be a reality. Our TSO, our Red Eléctrica, and the CNMC are now working in a draft that it must be go live last summer, but it's supposed to be a reality next year. In 2020, we will have the first open flexibility markets for all the customers. So it's not science fiction, it's a reality, and it will happen for sure.
The same question for the deployment of can you give you some figures when you think all the plan will be deployed?
So the target is in 2023, but the thing is, as I said before, as the EV cost will keep on decreasing and the target will get massive in 2-3 years from now, there is an aspect that I should remark that in Spain we are the second country after Italy with the lower ratio household and parking in the same building. So we need to be prepared. And although we have this target in 2023 in order to deploy the 8,500 charging points, we're going to sprint, and we should create this network before next year. And hopefully in January you will see already the first charging points. I invite you to download our application, which is US Pass. You will see already like 300 charging points in operation, but we'll keep growing continuously, and at the end of this year, the first quarter of next year, we'll have more than 1,000. Hopefully you can use it.
Thank you. Antonio, my question for you will be a difficult one. I am putting you a difficult one. You know, we talk a lot about circular economy. It sounds cool, like everything being recycled, you reuse everything. But the truth is, when you try to do the business case, circular economy is really, really complex to find because sadly, everything is cheaper to eject, to throw, and we see really things, even in the underdeveloped countries, very sad, like plastics being thrown everywhere. But the thing is that you as expert of circular economy, how do you think we will make this something that is not just a use case that you announced, a really circular economy everywhere? Because I think this is really the challenge and not easy at all. What is your perspective?
Okay, well, circular economy is about economy. If it's not economy, then it wouldn't be circular economy. What I'm trying to say is that when we implement projects or we identify opportunities for circular economy, there must be a case for that opportunity to be profitable, okay? You say linear economy, we throw away things, okay, and this is cheaper. Well, maybe cheaper, but you're not considering the impact that it has on the environment. Otherwise, it wouldn't be cheaper at all. So it's a challenge for sure. It's a challenge considering that we come from a linear economy and it has its impact, its difficulties, and we need to change our mind, and we need to change the way we do our processes within our companies and companies working together to become fully circular, but I believe that it's possible, and I believe that as society evolves and we internalize the problems that we are generating for our planet, okay, and for our society, we will come up with opportunities, and this is our objective, where circular economy makes sense, it's economically viable within Endesa or other companies, and it's the future. I mean, I think future society will be circular, or it just won't be. So we better get working towards that challenge, for sure.
I hope our innovability capabilities are able to really push this harder and harder. Final question, and with this we close the panel. For you, the question, how fast are we going to decarbonize? Because, you know, we get more and more worried with the, you know, now we have a Type 5 coming to Europe, which was the first time. This seems that every year there is more records, so how fast are we going to be able to decarbonize our generation?
Here the thing is that science is telling us we are not making it. And because we are not making it, society is demanding us to be faster, to decarbonize faster than we are doing. The new European Commission, they are already talking, or one of the things they want to do, they are going to put a lot of emphasis on climate, and one of the things they want to do, they want to update the decarbonization targets. The EU was supposed to decarbonize at up to a 40% in year 2030, and now we are starting to hear that it will be 55% by year 2030. So pressure will keep increasing, and we will have to manage to decarbonize as fast as possible. There are some technological issues we have to solve. In my opinion, the most important, energy storage. If we solve the problem related to energy storage, electricity will be fully decarbonized pretty fast, much more faster than what I told you.
Well, thank you very much. I think a big applause to all the panelists, and we end here. Thank you all for coming. I hope you enjoy our panels.